everybody. Thanks so much for coming to our talk about integrating Firebase into your existing backend services. I know that it's kind of dinner time right now, so we can really tell that you are the die-hard Firebase fans, and we're really glad to have you. I'm Jen Person. I'm a developer advocate for Firebase.
I'm Hiranya. I'm a tech lead for the Firebase SDK team.
So to talk about integrating Firebase into your existing backend infrastructure, we are going to be examining a made-up company called Fireflix. And we are currently collaborating with the team at Fireflix, which is an up-and-coming movie streaming service. And the Fireflix team is on a mission. They want to develop an app that enables their users to browse their growing collection of streaming movies. So that way, when you're on the go, on your phone, or even on your computer, you can check out everything that they have to offer, save movies you want to check out later, write reviews of movies you've already seen, and maybe even get some recommendations. Now, right now, they're off to a really great start. They have a few key core features to their app. But don't take my word for it. Go ahead and check it out yourself. So I have a short link as well as a long link. I won't be ashamed. I won't be embarrassed if you take out your phone or your computer right now and check it out. I will say that there will be something that'll pop up asking you if you want to get notifications. If you choose to do that, we promise we won't spam you. We're just going to send you a couple that you'll see as part of our talk. So I'll give everyone just another second to get to the link. This is your opportunity to be on your computer during the talk, and it's perfectly OK. OK, so let's check out what it looks like for everybody. If you want to go over to the demo machine, then everyone can see it, even if you don't pull it up on your device. And you'll see it looks something like this. We have this extended list of movies. You can load more of them. You can add it to your library. Let's say you want to keep track of everything you've seen, or maybe keep track of something that you want to see in the future. You can also add a review for a movie. Give that one 4 stars. You can give it a rating, and then you can give it a review. The text will be just for you, so you can remember what you thought of it. But the rating will actually be factored into the overall rating that people have made for the movie. Here we go. Submitted my review. You also see you can filter by genre if you're really interested in a specific genre. Check out your saved movies and your reviews, and this tab called My Recommended, which we'll get into later. And yes, feel free to keep playing with it. I especially recommend that you start making some ratings. Rate some movies that you really love, and also rate some that you are not a fan of. The more ratings you do, the more interesting one of our later demos will be. So again, it's OK to play with your phone during our talk. But at this time, let's switch back to the slides while everyone's playing. Here we go. So yeah, we have some great features, but we want to make the app even more sophisticated and engaging. We want to be able to add a moderator role so that some members of the Fireflix team are able to add new movies as they're added to their growing collection. We wouldn't want just anybody to be able to add movies, right? So it has to be designated admin users. We want to be able to implement secure backend services for managing all sorts of different app resources. And we want to leverage the company's existing search infrastructure to index app data and enable full-text search. That way, people can quickly look for the movies they want. You wouldn't want to just have to scroll through, I think, 10,000 movies. Yeah, you got to be able to search for the one you're looking for. Make movie recommendations to really pull users in, give them something that fits their specific interests, and keep users engaged by sending them notifications. And these are the examples that we're going to be examining today using the Admin SDK. So we're faced with a challenge that many app developers are familiar with. Successful apps do not exist in isolated silos. They look a lot more like this. They often collaborate and share data with various backend systems, cloud services, machine learning models, administrative tools, and legacy systems. So rather than just your little app in the middle, there's a lot more going on. Fortunately, Firebase has got you covered. And to tell you more about it, I'm going to pass over to Hiranya.
Yes. As Jen mentioned, developers working on sophisticated apps with complex requirements often need to access Firebase services and Firebase app data from their own backend systems. This is especially true in the case of enterprise app developers who typically have various in-house systems that should become part of their mobile and web ecosystems. But it could also apply to small-time app developers who may require some form of backend integration as their apps grow and evolve over time. This is where the Admin SDKs come into the picture. Admin SDKs enable you to develop backend software that interact with Firebase. And you can deploy them in an environment or in a server that you own or manage, like the servers sitting in your company's data center. Or if you are running some services in a cloud platform like Google App Engine or Google Compute Engine, you can use Admin SDKs to integrate those services with Firebase as well. Also, since the serverless architecture has now gone mainstream, you can use Admin SDKs to implement various serverless event triggers and deploy them in an environment like Google Cloud Functions. To make a long story short, Admin SDKs are available in 4 server-side programming languages. And you can deploy them in any environment that you control as the app developer and supports one of these languages. Now, let's move past the intros and really dig into some serious Admin SDK use cases, starting with the custom permissions model that Fireflix is trying to implement. Fireflix wants to define 2 classes of users, moderators and regular users. Moderators will have the authorization to perform certain privileged operations in the app, like adding new movies to the database. Typically, when a user signs into a Firebase app, Firebase auth issues that user something called an ID token. This ID token is then sent along with all the service requests made by the app. Firebase backend services authorize the incoming requests if they are accompanied with a valid ID token. The ID token itself is a short-lived JSON Web Token, or a JWT, with some metadata about the user encoded into it. They are signed by Firebase auth, so they cannot be spoofed. So one simple way to implement roles in a Firebase app is by instructing Firebase auth to add the roles information to the same ID token issued at signing. For example, since there are only 2 roles in the Fireflix app, we can tell Firebase auth to add a special moderator claim to the ID tokens issued to Fireflix moderators. In the backend service, we can check if the claim is present on the JWT to see if it came from an actual moderator. Now the question is, how do we tell Firebase auth to add additional claims to the ID tokens issued at user login? It's actually fairly straightforward with the Admin SDK. Let's go to the demo machine and look at an example. This is part of a Go web service that we have implemented to grant the moderator role to selected users. We start by calling the firebase.newApp function, which initializes the Admin SDK. This function takes a context and an optional set of Firebase settings, like the authorization credentials and project ID. But in this case, as you can see, we are not specifying any of those settings. We simply pass nil and let the SDK automatically discover all the required settings from the environment. Once we have initialized an app, we can use it to obtain an auth client or a Firestore client, which we would use later. We store these client instances inside a struct called admin client that we have defined in our code. Now, we can go ahead and implement the function to grant the moderator role to a selected user. The grant moderator role function takes the email address of the target user as the input. We pass it to the getUserByEmail function of the SDK. This function returns a record of all the metadata that Firebase auth currently knows about the target user. We can inspect the user record to see if it already contains the moderator claim. If so, then there's nothing else to do, so we can return early. Otherwise, we go ahead and call the setCustomUserClaims function provided by the Admin SDK. This function takes the unique user ID of the target user, which we can also get from the same user record that we retrieved earlier. and a map of claims to be added to that user account. Once this function has been invoked on a user, whenever that user logs into Firebase, Firebase auth will automatically issue an ID token containing those custom claims. Now, another thing to note here is, in this example, we are using the Go programming language to connect all the claims and user IDs together. But it doesn't necessarily have to be that way. If you have your own external user store, like an LDAP server or an Active Directory server, you can actually query that server from this code and use the results to decide how to set claims on different accounts. Let's go back to the slides. Having implemented the grant moderator role functionality, suppose we decided to expose it as a web service so that client applications can call it remotely and manage permissions. But in that case, we'd want to make sure that only authorized users are able to call it. We certainly don't want anybody to be able to just call into that service and potentially gain moderator privileges. That would be bad. Let's say, for the sake of argument, that only an existing Fireflix moderator should be able to grant another user moderator privileges. Same can be true for other critical backend functionality like adding movies. Only moderators should be able to do it. So how do we go about implementing a backend service that requires authorization from the caller? To meet this requirement, we need to guard all the critical backend functionality in our web service with a permission check. Let's go back to our demo machine and look at an example. So we implement a new function called checkAuth. This function takes the ID token of a Firebase user as the input. This implies that whoever calls this service will have to send the ID token along with the requests. Once we have received an ID token, we can pass it to the verify ID token function of the Admin SDK. This function performs a series of checks. It checks whether the ID token is a well-formed JWT, that it is not expired, and it is correctly signed by the Firebase auth. If any of these checks fail, then you get an error, which we can return back to the user. Otherwise, you get a decoded representation of the ID token. We can inspect this decoded representation to see if it contains the moderator claim. If not, we return an error. Otherwise, we signal success by returning nil. Once you have this checkAuth function, it's just a matter of wiring your web service so that all the incoming requests first go through the checkAuth function before hitting any of the other critical backend functionality like add movie function or the grant moderator role function that we looked at earlier. Now, we already have this web service up and running in the cloud as a Google App Engine service. Let's go to the demo machine, send it a few requests, and see how this permission check works out in practice. I'm using this Chrome extension called Advanced REST Client to send requests. And this is the URL that we have mapped to the grant moderator role function that we looked at earlier. This endpoint accepts a small JSON payload containing the email address of the target user. It extracts the ID token of the caller from a specific HTTP header. But first, let's just send it some request without any HTTP header and see what happens. So you can see you get a 401 unauthorized error response, and with error detail indicating ID token not specified. If you go back to our code, you can see ID token not specified is the error returned by our checkAuth function when there's no ID token available on the requests. Let's also send it some ID token value and see what happens. So X Firebase ID token is the custom HTTP header that our backend service expects. And I'm going to call it with this random JWT value. It's not a valid ID token. In this case, too, we still get a 401 unauthorized response, but it's a different error detail this time. This time, it says failed to verify token signature. This is an error returned by the verify ID token function. So you can see how the checkAuth function and the Admin SDK prevents different types of unauthorized access attempts to our backend service. But now let's go ahead and try to call it as a valid moderator with the correct permissions. Now, I've already set up my personal Fireflix account as a moderator. As a result, if I log in to my app, I'm shown an additional moderator tab that you probably don't see on your screens. And on the other window, you can see that's Jen's account. You can see that she doesn't have moderator privileges at the moment either. The controls in this tab allow me to call the same backend service on App Engine, and these controls will take care of sending my ID token along with the request. The permission-driven UI experience you see here is implemented by parsing the ID token on the client apps and checking the result to see if it contains the moderator claim. It's not a very secure check since it's client-side. There are ways to get around it. But that's OK, because as we saw earlier, our server implementation has its own and more robust permission checks. So I'm going to use the Add New Moderator form to give Jen moderator privileges in the system. Maybe I would ask Jen to type in her email. And this time I get a successful response. Okay. And hopefully Jen can log back in and show off her newfound privileges. I
promise not to get drunk on power and add too many movies. But if you see some silly movies, later on it was probably me. Yeah, so now you can see that the moderator tab shows up for me as well. And I have the ability to add new movies as well as additional moderators. Can we go back to the slides? So let's talk a little bit about what those custom claims can do for you. We have looked at 2 examples of where you can use those custom claims. In your server environment, where we had the check-auth function, and also on the client, where we had sort of just a silly check that hides something from developers. Of course, again, if you're a developer, you can probably expose that tab, but you won't be able to make any sort of requests with it because you are not authorized to do so. The other place that we did not examine using these custom claims is within the Firebase server. So if you are using Cloud Firestore or the real-time database or cloud storage, you can use custom claims in the rules that you set up in your database to manage what people can read and write. Just this very simple example that we have here of how you could set up your Firestore rules. If I have a movies collection, I can allow anyone who is authenticated to read. Because we have anonymous auth set up, that would be anyone who has accessed the app. But in terms of writing, we could set it up so that if the auth token has the moderator claim set to true, then they're able to write. Otherwise, it will return an error saying that you do not have permission. So let's take a look at another example of integrating Firebase into your existing services. Currently, Fireflix has an Elasticsearch cluster that they're using. They use it to power a number of their search applications that they have. And they want to use the same infrastructure to index Firebase app data and to support new keyword search so you can look for movies by genre or by title. You know, in an enterprise customer, this is a very common use case. You already have some things in place. It may be a little difficult to sell someone on starting something new. You can, in fact, incorporate Firebase into this. So currently, the app needs to update search indexes just when movies are added. But in order to prepare for future changes to the app, tracking all of these can be very difficult. If only there were a way to trigger some backend code in response to Firestore update events. Of course, Cloud Functions for Firebase, which I'm a huge fan of. So you can deploy some Node.js code to automatically trigger when certain events occur in your Firebase project. And these could be something auth-related, like adding a new user. These could be writes to the real-time database or Cloud Firestore. There are a lot of different options, but the ones we're going to examine today are going to be based around Cloud Firestore, because that's what we're using in our app. So the first example we're going to look at is updating those indexes. What we want to do is whenever a new movie is added by one of us to the Cloud Firestore, we want to trigger those indexes to update. So we have a proxy that talks to Elasticsearch using its internal IP address, because they're both on the same private network. In this case, we're talking about App Engine. The proxy is exposed using custom HTTP auth. Now, this is just one way that you can do it. There are certainly other options, but we'll show you what this looks like. So let's dive into that Firestore trigger on our computer. Put this down. So you'll see here that we import the Admin SDK as well as functions. And when we initialize the app, we can do so calling just admin.initializeApp. Just like we did with our Go code, normally we may need to pass in some credentials, but because we are in a Google-managed environment, we can just call initializeApp, and Google does all the work for us, which I just love. Let's take a look at our update search index function. This is the format that you'll see for most cloud functions. We have functions dot some feature, in this case, Firestore, and then the specific document on which we want it to trigger. So we have a collection of movies, and inside that are a series of documents, each with a unique ID. The brackets indicate a wildcard. Whatever that movie ID is, we want this to trigger. This triggers on write. And on write means that anytime something is changed or written to that location, this is going to fire. When you first write, when you make a change, or when you delete, then this code is going to run. Our parameters are change in context, and we have a couple examples of how you use each of these. For instance, if we want to get the data after a change occurred, we do that using change.after.data. And that'll pull all of the information inside of the document. In this case, all the details about the movie, its title, its genres, et cetera. We also have previous, which if there's any previous data, say it's not the first time writing to that location, we can get the data that way. Otherwise, we're just going to have an empty object. We do a couple of quick checks before we go updating our indexes, because there are some situations where we won't need to do that. So for instance, if the type of data is undefined, as in the movie was just deleted, we're going to return a promise that is resolved with true. And we return out of this to clean up the function. It doesn't need to do any more work. Otherwise, we check if the title or the genres are changed. If they weren't, again, we don't need to update the indexes, because currently, that is what we are indexing. If it passes those checks, then we have our secure proxy service. This is our endpoint. And we have some options. This is where that context parameter comes into place to access that movie ID. So we want to get that unique key. This is how you can access it from within the function. And we get the title and the genres. Then we have this really sophisticated-looking authorization header, which says functions.config.fireflix.token, which sounds like something maybe sophisticated from within Firebase, but it is just an environment variable that you can set up from the command line interface. So when you deploy your functions and all of this code is available, there may be some information that you don't want to deploy with it. Like if you have some sort of password, or in this case, some key that we want to hide, you can hide it inside of your environmental variable, setting it up in the command line interface. So you can call it whatever you want. We called it fireflix.token. You can call it banana, and you can give it whatever value you want, and then access it from within functions.config. What the token is doesn't really matter. We just made it something arbitrary that the server-side code knows to check for. Finally, we make a post request, and we update that index. If there's an error, we catch it. And then we always end by returning to clean up the function and tear it down. Can we go back to the slides? Thank you. So similarly, on the client side, when a search is made, it also goes through this Elasticsearch proxy, and then the results are streamed back to the client. So either way, we're keeping that information secure and not accessible to the client. We can also use Cloud Functions to automate other tasks. I have so many ideas about what we can do, but I just looked at a couple. So for instance, we can notify users about new movie additions to try to engage them with what we're adding to our collection. And we can use Cloud Functions to automatically keep movie statistics up to date as ratings trickle in. This is a very common use case where you might have some number that you need to keep track of, a total or an average. Cloud Functions are great for that because they can trigger and run automatically anytime something else is written to the database. So let's go back to the demo machine to look at those examples. Can we check out the demo? Cool. So we have the send and release function, which looks very similar in format. Again, it's functions.firestore.document. It's going to be triggered anytime a movie of any ID is added to that movie's collection. But in this case, we're looking at an onCreate trigger, which means it's only going to run the first time something is written to that location. We don't need to notify people if we change something in the spelling of the title or add a different genre. We just want it to run the first time and notify users of our new movies. The parameters are slightly different as a result. We don't have change. We have snapshot because there is no change that occurred. There's just the original write. But again, we use .data to access what was inside of the write. We use the Admin SDK to access Firebase Cloud Messaging. And Firebase Cloud Messaging enables you to send data messages and notifications to iOS, Android, and web. So this way, we can send our messages to our users no matter what platform they're on. We have just a simple topic and notification. We get the title of the movie from that snapshot data. And then we use the Admin SDK to send that message. Then we just log that we sent it. And we finally have one more example we're going to look at, which is updating those ratings. This time, instead of the movies collection, we're looking at the ratings collection. And inside of that, we have a movie ID. Under the movie ID, we have just a whole bunch of user IDs of anyone who's written a rating of that movie. And then the value is the rating that they gave that movie. So boom, whenever a new rating occurs, we want this to run. So again, we have an onWrite trigger. It's going to get the change after. We get all of the keys, so we can basically count up how many reviews there were, so we can get an average. Then we compute the average rating and use the Admin SDK to write it back to the database. Notice we use doc.set to set those key value pairs, but we also use merge true. That means instead of replacing the entire document, we're just merging together, adding these keys rather than replacing everything else that's there. We don't want to replace the ratings that are already there. So that's a lot of code to look at. It'd be kind of cool to look at an example. So let's add a new movie. Let's see. This, I think, is going to be a bestseller, incorporating Firebase into your existing backend infrastructure. I'd say this is an action, a little bit of comedy, drama. Submit my movie. And it says it was successfully added. So now, I should be able to search for it. Notice the function was triggered to index my movie, so I'm immediately able to search for it. And I can add a review of it. I know this is under your account. I hope you don't mind. I think it's 5 stars. Will watch again. Review is submitted. And then, if I take a look, my average has been updated. And if you give it a rating as well, you'll see that the average will be updated. You might not see it on other movies because we have so many ratings for other movies that are in there. But again, just a reminder to put in some ratings because you're going to really want them for this next part. So let's head back to the slides.
Fireflix would also like to unleash some of the machine learning tools developed by their data science team on the ratings collected by the app. Specifically, they have built a collaborative filtering model in TensorFlow to make movie recommendations. This model needs to be trained periodically, and Fireflix would like to do so using their own servers. The movie recommendations that result from this computation should be fed back to the app so the users can see the results on the screen. The TensorFlow code is written in Python. So in this case, we can use the Python Admin SDK to directly interface Firebase with the machine learning code. We can use the Firestore API available in Admin SDK to query the app database. The movie ratings fetched in this manner can be directly fed to TensorFlow or any other Python number crunching tool that you want to use. In the same way, the results of the machine learning tools can be written back to Cloud Firestore. But we also have the option of directly notifying the Fireflix client apps through FCM if machine learning tools uncover something noteworthy that the user should be notified about. Now, this machine learning code is going to take a minute to run. So let's go to the demo machine and get that going first. And let's go into a quick code walk.
Yeah, we're doing a lot of live demos. We're very brave.
Yeah. Hopefully, it will be running in the background. And let's go to the code. The Python code is organized into 3 high-level steps. In step 1, we initialize the Admin SDK as usual, and then query the app database for all the information we need. As you can see, again, we are not passing any arguments to initialize app call. If executed in an environment like Google Compute Engine, this will seek out application default credentials and automatically connect to the Firebase resources associated with your GCP project. But you can, as you can see, you can get this style of parameterless initialization to work on your own machines, too. Currently, this is running on my machine. And you do that by installing a service account to the environment. To query the app database, we import the Firestore module through Firebase admin. If we go to the very top, yes, we import the Firestore module through Firebase admin and then use it to get hold of a Firestore client instance. And then we can use it to retrieve all the ratings accumulated in the ratings collection. There are around 100,000 ratings in our demo dataset, plus whatever the ratings that you were nice enough to give during this session. So this query can take around 4 to 5 seconds, depending on the network speed. In addition to the ratings collection, we also query the users collection, where we have stored your FCM registration tokens. We will use those tokens later to send notifications. Next up, in step 2, we run this data through the TensorFlow model and make movie recommendations. Now, I'm not going to go into the details of that, but if anybody's curious, just come find me after the talk or tomorrow at the Ask Firebase sandbox, and I'll be happy to walk you through as to how we did that. It's a singular value decomposition model for if you're really curious. Finally, in step 3, we write the movie recommendations made by TensorFlow back to the app database. Now, this can potentially result in a large number of small Firestore writes. So to make it a little more efficient on the wire, we split our recommendations to chunks and then use the batch write support available in Firestore API to write 500 recommendations at a time. Having written all the recommendations to the database, we also use the FCM support or the messaging support available in the Admin SDK to send notifications targeting individual users. Now, hopefully, the script has run to its completion by now. Let's see how did that go. Yep. And that means we have some recommendations to look at. Let's go to the dual screen setup.
Let's see both of our screens so we can check out both our
So
movies.
here's a notification that I've received. We have found some new movies you might like. That's the Python code notifying my app instance. And let's see if
It just takes a minute. There it goes.
So let's see if there's anything that I would actually want to see here.
Ooh,
Avatar
Ice
is a good
Princess.
one.
I definitely want to see that.
Con Air is a
Just
good
kidding.
one.
I already have.
So looks like I'm getting a lot of sci-fi action type movies. And I actually do watch quite a lot of sci-fi and action type movies.
Yeah.
But
I'm getting a mix of some indie movies, some sci-fi, and also some animated. So yeah, I'd say pretty accurate.
yeah. Hopefully you get something more sensible too. It works a little better when there are more recommendations from the same user, so not just the high ratings, but low ratings as well. Let's go back to the slides. We've actually made a lot of progress at this point, so it's a good time to take a step back and look at what we managed to deliver. We started with a fairly straightforward app that supports user authentication and some database interactions. We overlaid a custom permission model on this app using Firebase Auth. We used the Go Admin SDK to set custom claims on selected user accounts, which we can validate using the Admin SDK itself or Firebase security rules. We leverage this permission model to implement a backend service that only Fireflix moderators can access. Moderators were able to use this service to add new movies to the database. Then we use Cloud Functions for Firebase to integrate the in-house search platform at Fireflix with the app database to support full-text search within the app. We use Cloud Functions for Firebase, which tracks the updates that go to the app database and then indexes them in the private Elasticsearch server. We expose the Elasticsearch server to Cloud Functions as well as the client apps through a proxy service that we deployed in App Engine. We also use the Node.js Admin SDK to keep the movie statistics up to date and send notifications about new movies. And finally, we use the Python Admin SDK to harvest all the ratings collected in the app database, run it through a TensorFlow model, and feed the resulting recommendations back through Cloud Firestore and Cloud Messaging. So this is what the final enhanced Fireflix app architecture looks like. So you can see it's no longer a simple, straightforward app, but it has become a fairly sophisticated system where several in-house services and several Firebase services work side by side. And chances are, if you're an enterprise app developer, your architecture already kind of looks like this. If you're a small-time app developer, don't feel left out. As your apps grow over time, they might begin to look a little bit like this. And as far as the Admin SDK capabilities go, we just scratched the surface today.
That's right. There are a lot of other examples of ways that you can integrate the Admin SDK into your apps. So here are some good examples that we did not touch on today. Gdpr is a big topic right now. You need to be able to delete your users' data. And the Admin SDK gives you the opportunity to delete instance IDs and other private data from your users when needed. You're also able to use it to access Google Cloud Storage, the Firebase real-time database. You can manage your FCM topic subscriptions, so you can add people to specific topics that they want to get notifications about and remove them, et cetera. You can also use it for custom auth. So again, if you have some sort of system that is required to be used at your company, you can still integrate Firebase using that custom authentication in the Admin SDK. You can also use it for bulk user import and export when you need to make those big changes. If you have a traditional web app that's using web session management with cookies, you can do that. Yeah, there's so much more. I mean, more than we can even fit on this slide.
Yeah. And also, incidentally, Admin SDKs is one area where we'd like to welcome your input and help as well. Firebase Admin SDKs are developed in open source, so feel free to file bug reports, suggest new features, and just point out areas of improvement in general. And also, if you have the time, please keep those pull requests rolling in as well. We love working with our community and are always looking to get more developers involved in the process. Isn't that right, Jen?
Absolutely. Yeah, we'd love to hear from you. So in addition to rating movies, you can also rate our session on the Google.io schedule. And also, you can reach out to us and tell us what you think. We will be in the Ask Firebase area of the tent tomorrow morning, probably all morning. But
for a good chunk of the day.
Yeah. And then you can contact Hiranya on GitHub. You can see his handle here. And you can find me on Twitter at @thatgenperson. Thanks so much for coming. It's great to have you.
Thank you.